Hey everyone, welcome to 5.1, the examples. So we're finding the derivative of the natural log of x. If you remember from the last video, the derivative of the natural log of x is just 1 over x, where x is greater than 0. That's just the basic function. If we just have natural log of x or something easy like that. What happens if you have the derivative in terms of x of u, where it's going to be 1 over u du dx, which is the same as u prime over u. That's the one we're dealing with substitution. So if it gets a little more intense, then we have some possible solutions. Okay, so what we can say is that here, it's not just x, so we can say u equals 2x, and we can say u prime equals 2, right? So now we can say the derivative of this whole thing is going to be u prime over u, right? So that means it's going to be 2 over 2x, which is the same as 1 over x. Alright, there's the first one. Let's do the next one. The natural log of x squared plus 1. Well, this whole thing we're going to say u, so we're going to say u equals x squared plus 1. We're going to say u prime is going to equal 2x plus 1. No. Okay. Good. So then we can say u prime over u. That's just 2x over x squared plus 1. That's it. There you go. So there's the next one. Now let's say, what's the derivative of x natural log of x? Ooh, interesting, scary, not really. Product rule, right? Product rule. Derivative of x is 1 times natural log of x plus the derivative of natural log of x is 1 over x times x, right? So then 1 over x times x, that just equals 1. So it's really the natural log of x plus 1. Got it? Great. Okay. And now, derivative of natural log cubed of x. Okay. So, what do you think we should do here? Think about it. Are you still thinking? Well, we're taking a derivative and we have an exponent. So, what we do all the time is we put it out in front. Right? That's not going to change anything. We've been doing this for a while. So we can say that's the same as 3 natural log of x squared. But now we have to do that chain rule. Now we have to take the derivative of that thing. Right? What's the derivative of natural log of x? Well, that's just 1 over x. Right? Yeah. So, can we just simplify this up a little bit better? 3 over x natural log of x squared. Now, I would suggest putting the parentheses around here because this is not the same as 3 over x natural log of x squared, right? Because the square here is only going with the x, or the square here is going with the whole natural log as well. All right, so there you go. There are some example problems on how to do those. Let's do a couple more examples here. Let's differentiate the function of, there we go, the natural log of the square root of x plus 1. Okay, the first thing I'm going to do to make this a little bit easier, you could say let u equal the square root of x plus 1, but don't do that. Think about your properties of logs, right? I can say this is going to be the same as the natural log of x plus 1 to the 1/2. And then, what do I know about the properties of logs? What do they tell me? That's going to be the same as 1/2 natural log x plus 1. All right? So we could say u prime over u, but really all we have to say is this is going to be the same as 1 over 2, and the derivative of this is just going to be 1 over x plus 1. I mean, I can take u prime and say u prime of this whole thing, what's the derivative of x plus 1? Well, it's just 1 anyway, so I can just put it over 1. So then we could say this is the same as 1 over 2x plus 2. And there you go. See, this really isn't too bad now, is it? Okay, let's differentiate. Uh-oh. Just when I said it's not going to be too bad, I go ahead and give you a problem like this. Yeah, but calm down. Use your properties of logs, and let's get this correct. All right, so the first, I see multiplication between these two. I see an exponent, and I see division, and I see that. So what I'm going to try and do is I'm going to break them apart into 3 logs first. Multiplication and division. When I rewrite them, it's just addition and subtraction. So I want to try and do that first. So I can say g of x is really going to be the same as the natural log of x plus the natural log of x squared plus 1 squared minus the natural log of the square root of 2x cubed minus 1. Okay? Alright, so now I see this square and I see this thing, and I'm going to say, can I simplify these? This one's still going to be the same as the natural log of x, and when I take the derivative of that, that's going to be easy. I'm not worried about that, because that's just going to be 1 over x. Okay, this 2 is going to go out in front. I'm going to say 2 natural log of x squared plus 1. Okay, not too bad. And this is really the same as to the 1/2 power, right? That's what that means, so I can say this is minus 1/2 natural log of 2x cubed minus 1. Alright, so if you want to say what g prime of x equals, well, I know this is going to be 1 over x. That's easy. For this one, let's just say that u equals x squared, so x squared plus 1, and u prime is going to equal 2x. Okay, good. And then let's say for this one, u is going to equal 2x cubed minus 1, and u prime is going to equal 6x squared. Right? Okay. So now what we have to do is just rewrite that. The 2 still goes here, and it's just u prime over u. So it's going to be 2x over x squared plus 1. And then this one is going to be minus 1/2, and it's u prime over u. So it's 6x squared over 2x cubed minus 1. There we go. So now all we have to do is just clean this up, make it look a little bit nicer, maybe reduce anything if we can, or multiply some of the stuff together. So we can just rewrite this final answer as g prime of x equals 1 over x. 2 times 2 is going to be 4x over x squared plus 1. Put the plus in between them. Alright, and then the last one, the 1/2 and the 6 cancel out, so that's going to be a 3. So minus 3x squared over 2x cubed minus 1. Hey, there we go. That's it. It's right here. Okay, so it seemed kind of intense, but all the properties, if you can keep them straight, make it actually pretty simple. So hopefully that helped out. Good luck, and I will talk to you real soon.